Okay, so we've brought a bit of old school stuff and we've got a bit of the new stuff just to show you also how the technology has changed, not just what it does, but the size of things, how they've made things a lot easier. All right, so in the old days, there was no wireless communication. You know, pre-wireless, there was only wires. So how did you get a signal from here all the way to something here, which is, say, your control room? The only way to do that by wires is telephone. Yeah. So in the old days, you had telephones, which was connected to an exchange, and then eventually the exchange was connected to the control room. And the only way to dial the control room now is actually they had to sit with a whole bunch of phone lines that your device dialed through. But in order to dial through, your alarm panel has to have what's known as, a telephone dialer. So this telephone dialer, physically, you programmed in the telephone number, one of these lines that came into the control room, and it dialed. And on the other side of each one of these lines, you had a base station.
Each one?
Each line had a base station, or a base station had multiple lines. I mean, that was also possible. So it means that you could only receive signals when that line was free, because you can't phone an engaged line. Okay, so this is old school. This is 30, 40 years ago. So it would dial, and between here and here you'd have a communication of all sorts of tones and saying, acknowledge, yes, I've received the signal, this is my signal. It dialed the number. This answered, it says, send me your signal. It sent the signal, and it sends back the acknowledge to say, okay, I've received your signal, and then just terminates the phone call, and then that's how the control room received the signal. Obviously, from the base station, it was connected to the control room software, where they do all the monitoring. In the olden days, I don't actually know what was used, but we used to have an application called CRAN, which was DOS-based, which was our first control room monitoring software. But I'm pretty sure that there were other softwares. Right. So that was the communications through wires before the wireless communication. So what happened when wireless came is that it completely did this. We took out the phone line, and it took out the phone lines here. And what we did is that instead of going there, we put a radio with an antenna, connected the same line, the same dialer line, and over here we had, okay, maybe we should unplug this.
Oh, I can switch it off.
Yeah, okay. All right. So then on the base station, these were now radio base stations. And what happened is that this panel would still dial, thinking it's talking to the base station, but it's dialing into here. So this is simulating what the base station used to do. So now that same communication between here and here to saying, okay, I'm ready for your signal, send the signal, okay, I've received the signal, you can stop. And once it's received that signal and it's done all the checks that nothing was corrupted, then it will send it in that way. And funny enough, just as I was speaking, what you heard there was exactly what it sends. You can kind of make out that it's all different tones that you would have dialed very quickly on a keypad of a phone, old school phone. So this is just simulating a telephone line. Okay. So what was sent there is known as ContactID. ContactID is not, it's got nothing to do with the type of transmission. It's got to do with the data that is sent between here and here, which used to be the data that was sent between here and the base station. And each one of those tones that you heard is a number on the keypad, essentially. You've got 1 to 9, you've got star hash, and then you've got ABCD. Yeah. So you've got 16 different types of numbers that you can send in a transmission, and that will tell you which zone, what type of alarm, was it panic, was it, all the different types. And ContactID has a certain format, which maybe we won't go into here because it's not really useful, but it tells you information. So you've got the radio number so that the base station knows who sent it. Then you've got an event type, so I'll just put radio, and then here you've got, say, event. Maybe this is event type. This one here is actually the event, meaning that event type was meaning that if it was a new alarm or if it was back to normal, for example. So we call it alarm and restore. So when you trigger an alarm input, it goes into alarm, and when it goes back to normal, then it sends a restore. So this one will either be D or R, store and event and restore. And then here you've got 3 characters. I'll just put X, 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 which identifies your type of alarm. So panic, medical, zone alarm, bypass. You know, so you've got a maximum of, say, 999 different types of events that ContactID. And in the same way, yeah, this doesn't actually mean an alarm panel. This could also be a fire panel. Anything that's dialing ContactID, it's sort of a universal format that everybody's adopted. So, and then of course you've got the zone. So if it was an alarm, which zone was it? You've also got a user that's part of here. So who armed the alarm? Which user was it? Which partition? All of those things. Okay. So this format here is what is sent between here and here.
And is that all numbers, though? They've got radio.
Numbers and letters up to F. Let's call it.
So radios is numbers. Event type is that.
All of them can be alphanumeric up to F.
Okay.
Yeah. 1 to 2 was in at 9.
And that's what's coming on the base station screen, eh?
Yes, exactly. You'll actually see that as raw code. On the
just for people that don't know.
Yeah. Okay, so that is what it was done. So ContactID's got nothing to do with this, because you'll see in later technology we still send ContactID, but we send it over GSM, we send it over Sigfox, we send it over LoRa. So ContactID's got nothing to do with how you're sending it, it's what you're sending. Okay, so that's basically what has happened, is that your radio is simulating an old school base station. So you can imagine you're not saving too much time, really, but you're not holding the line while you're dialing. You know, you're dialing, you're capturing, and then you send it very quickly, and then the base station decodes that. Whereas in the old school, while you were connected, you were dialing and it was decoding. So now all this does everything. Maybe it gets a few alarms, stacks them up, and then it sends them quickly out. So this is relatively slow. I mean, in today's age, dialing is still relatively slow, because by the time you're breaking to run to the alarm panel, theoretically, if you know exactly where it is, you can intercept, get to that dialing thing, unplug the radio, and then nothing gets received. So we'll talk about later then how we solve that. Okay, so then this is ContactID. I'll just call it CID. But what could also be sent is MAMI format. For example, we've got our own format which is similar to the ContactID, just the way things are structured is different. But if you had to hear, it's much quicker. It sends the same sort of way with the tones and all of that, but it's a little bit quicker. Okay, the other thing is that this was always one directional. You had a transmitter and there was a receiver in the base station. You couldn't send anything back to do anything to the panel, which was quite important. And why? If you just take a look at the technology, I mean, this radio, this was just the transmitting radio. So if we had to basically compare that, this whole circuit has now become this little circuit here, just this shiny little silver thing, with a ton more of stuff that it can do. Yeah. So what the new stuff does is that it allows you two-way communication. You could also do that in the olden days, two-way communication, but then you have this whole board. You've got the transmitter circuit and you've got the receiver circuit. All of this now is inside that little silver thing now. Essentially what we were doing here is our radios were sending, say, 15 watts. 15 watts of power is a lot of power these days, because all the new stuff is maybe 100 milliwatts. So if you had to convert this to milliwatts, you'd be sending 15,000 milliwatts, whereas the new stuff is sending it's like
It's
150 times less power.
And you're doing a whole lot more.
Yeah, you're doing a lot more. So, but you know, why can we do it? Because there's been new developments in the way you're sending data, the way it transmits, you know, from one to the other. You can send it a lot faster, because in sending this, it took very long for a transmission. Whereas when this sends, it's you know, there's hardly any time for you to hear it. So there's a big difference there between the old and the new technology. The old technology you could easily reach 40, 50, you know, however the curvature of the Earth goes. You know, with 15 watts you probably could go as far as you can see. Whereas the newer stuff you can also, but it's very directional. The other difference is that this was usually on VHF, which is say in the 140 megahertz band, whereas the new stuff you're talking about say 868 megahertz. So you've doubled to 40, you've doubled, and then you've doubled again. So you've moved up in frequency. Moving up in frequency allows you to send much faster, because it allows you just to send, to clock out the data much faster. So that is the new things. So so this was one-way communication, and eventually the whole market changed, and we had the introduction of GPRS. Yeah. So between this and the new stuff, we had GPRS. And what happened there is that our radio was exactly the same, except now it wasn't VHF. We had now a GSM unit there with a SIM card, and that connected to, you know, a tower. And that tower eventually found through the mobile phone network. Eventually, it found its way to the control room base station. The base station now had to have its own module, GPRS module, or whatever it was, SIM card, and then it would receive that. So, but it allows you to be anywhere in the world, theoretically, that there's cell phone coverage. And that was the big thing. You didn't have to be in range.
Also one way.
Two-way, yeah. So GPRS allows you to communicate there, or you could be standing here with an app on your phone, and then you push the data to the cell phone network, and it would find its way back to there. So GPRS was probably the newer technology after the VHF that allows you to do the two-way communication. And that went on long. We had 2G, we had 3G, and then we have 4G now. G standing for generation, if anybody didn't know. Second generation, third generation, fourth generation. And now you've got all different types of fourth generation stuff. You've got the LTE, you've got LTE category 1. Category 1 is a subset of the LTE. It's up to 10 megabits, which is more than enough for our, it's probably not enough to browse and to use your normal stuff, but for sending some alarm packets, more than enough.
Is that what we use?
That's what we use, correct, yeah. So we're on 4G LTE Cat 1. And of course you've got all the backwards and forwards communication. Right, so then came the introduction of what is known as 0G. So we weren't going this way, we went back the other way. So 0G is your, it was sort of a buzzword when all the IoT, the word came about. IoT stands for Internet of Things, which basically means you've got a little device and somehow you're connecting it to the internet. That's all it means. It's still an RF communication. It's still talking to something via radio waves in the same way all the other stuff does, just a different way, absolutely. Yeah, so Internet of Things, it means that you've got this little device, somehow it's getting data onto the internet. So 0G was brought about to use very little transmission. We didn't have to have SIM cards, you didn't need to have too much data, because you were just sending small packets of data. and you didn't have to send it that fast either, just because it was a little bit. Whereas 4G and all of that is always talking. You can hear when you put your phone next to a speaker, or whatever. It's even if you're not doing anything, it's constantly sending. So the 0G helped to reduce power consumption massively, because it wasn't always sending. It was only sending when you told it to send. It wasn't trying to associate to different networks and different towers and whatever it was. It only sent stuff when you wanted to send it. So very low power, which is why all of our tracking devices can use 0G, and 0G is broken up into a few other things. But because it only uses power when it transmits, you can make something completely wireless. Okay, so then came IoT, and IoT, the two leading technologies was obviously Sigfox and LoRaWAN. So essentially they are the same because they both work on 868 megahertz. I'm assuming that this is in our zone. For example, in Australia and America, it's 915.
And there was another country, was it with Chile or someone?
Yeah, so South America,
It's also
915, yeah. So it depends wherever you go. There's certain regulations that says this band is allocated and you use it. What is nice is that this is non-licensable. So you don't have to pay a frequency license. All the old stuff that we had, you know, the 15 watt transmitters, you had to buy a frequency license. It was a dedicated frequency to only you. And only you were allowed to use it, but you paid monthly to ICASA, or yearly for a radio license to ICASA. Okay, so both of these technologies, both Sigfox and LoRaWAN, used 868. And the main difference between them is that Sigfox was a network, and LoRaWAN was a technology. So what does this mean? Is that if you've got a Sigfox radio, you subscribe to their network. What you pay for and what you develop is using a Sigfox network. They maintain where all the base stations are, they make sure that there's power at the base stations, they make sure that the base station has connectivity to the cloud, to the server, because when you send a signal from a device, say on the tower, we've got the Sigfox antenna with its radio, your device will send to the tower. The tower will have internet connectivity, which will put it then on the famous picture of the cloud. And then on the other side of the cloud, it comes out, and then you decide what to do with that data at your control room, on the app on your phone, whatever it is. So it's basically a link from your device to the cloud, which is why we go back to the IoTs, that you're literally putting stuff directly onto the internet through a gateway. So gateway receives something, converts it, and does something else with it. So that is exactly the same. The same layout works for LoRaWAN, but you don't have to use their network. You can put up your own network. And that's the key difference, is that you can manage and maintain your own network with LoRaWAN. You don't have to, there's no really recurring fees to anybody else, which people like a lot. But when you start moving to a national level, you have to remember that you have to maintain your own base stations now. There's nobody maintaining it for you because there's no subscription. Whereas Sigfox, you're paying a subscription. Their job is to make sure that the network is stable. So there's very different use cases, and I wouldn't say that you can just swap whenever you want. They have very specific things, like you couldn't drive from here to Cape Town and expect to track your device if you're on LoRaWAN. But because Sigfox has a national footprint, they can easily, they've got towers all the way nationally, and wherever you go, it'll work. What is also good is that anybody that's inside the Sigfox zone, it's called a zone, your device will work. So if I had to take any of our Sigfox devices anywhere in Europe, they'll work straight away without changing anything.
Wow, I didn't know that.
So that's also what's very good, but you can't take your device to, say, South America, because it's a different frequency range.
Yeah, it's the point to ask you, but
Yeah.
as long as it's in the same band.
Yeah, correct. So we're known as RC1. that is the 868 band, which is Africa and Europe. Then like Malaysia, China's got their own, Australia's got their own, America and South America also, 915.
China's one we obviously don't know what it is.
Yeah, I'm not too sure, but it's going to be all the way somewhere
Around
here.
there.
Yeah. What else? Okay, so that is Sigfox. So they maintain the network. So now LoRaWAN allows the customer to manage their own network, which is very useful if it's an estate or if it's someone that has access to go and maintain their own house sites. If you can do that, it makes absolute sense. But not only maintaining the house site, you have to maintain the connectivity. If that gateway, so it's the same structure as this, but if that gateway, say the internet drops there, say your SIM card runs out of data, or say lightning hits, it's your responsibility to go there and fix the radio. So it's very similar to our repeater network, our VHF repeater network, which is why it might be an easy crossover for existing customers, because they're already maintaining their own repeaters. They already have their VHF repeater on a tower, or they already have, they're already doing batteries, they already make, but now they have to just check one more thing, is that there is connectivity.
But now that relies on cell phone coverage.
So, essentially it depends, because your gateway somehow has to connect to the internet. So yes, the easiest way is just to pop a SIM card in there and then it jumps onto the 4G. But then you've got issues like load shedding and all the usual stuff that happens with load shedding. So then you have to put two SIM cards. Maybe it'll jump onto a tower that hasn't been load shed. And of course, the best would be if you have some kind of connectivity to wherever you're making.
Like a fiber, Ethernet,
fiber, Ethernet, whatever it is.
Yeah.
The other option is you put a dish facing another dish on another tower.
With nano's, eh?
Yeah, as long as you get connectivity, and this thing here has connectivity to the internet. So as long as you somehow find a way to get to the internet, you can manage it. So the only real recurring would be your connectivity.
Which if you're a state and whatever they've got generally anyway.
Yeah, exactly.
In terms of the data they send in, is it big?
Very small data, very small data. So it's like bytes of data. Maybe it's not understandable, but it's like, usually you're doing megabytes and gigabytes. This is not even kilobytes, this is bytes. We're talking about like 20 bytes. So you don't need much bandwidth. Okay, so the other difference between Sigfox and LoRaWAN is the way you can talk back. So they are two-way, there is two-way communication between Sigfox and the network, but the difference is that Sigfox, you cannot talk to a device whenever you want it. It has to be in a listening mode, and you cannot put a Sigfox device in a listening mode. The only time it goes into listening mode is when you've sent up. So when our device sends a signal to the tower, it automatically listens for a little while after that, waiting for your reply back to it to tell it to do something. You cannot at any time just send a signal to a Sigfox device because it's not listening. And that's the key thing to remember, is that Sigfox is a two-way, but not really. It only listens when you've sent a signal up. Maybe for a second or two after it sends its transmission, it listens and it says, do you have anything for me? Nothing, and then it goes back to sleep. Or in that time you've sent something to action, like trigger a relay or disarm the alarm and all of that. So that's why our devices, we cannot really sell and arm and disarm on a Sigfox, because you cannot force it to arm and disarm if it's not listening. What you have to do is allow it to check in and then send what's known as a callback back to the device while it's listening, and then it does what it does. So LoRaWAN is exactly in the same way, but it allows you a little bit more expansion. You've got different classes. You've got A, B, and C. Class A is exactly the same as at Sigfox. It only listens when you've sent up. So this is the lowest power mode, if you want to call it, for LoRaWAN. B is a little bit of a combination, so it listens every now and then, and you have to synchronize time now, because the network has to know when that device is listening. So if you send something, you don't have to wait for it to send up. It'll wait for its like time slot to come, and then it'll send it down to the device. So that's class B. Class C is the worst power consumption because it's always listening, but it allows you to send a signal at any time, other than when it's sending up, of course. But you can send a signal to the device whenever you want. So in class C, it's always listening. That's why it uses the most power. But you've got a full two-way communication whenever you want. And that's a big difference between Sigfox and LoRaWAN. But it depends on the use case, because you can't have like our recovery tracker always listening, because the battery will
Charge
not
the
last
battery.
exactly. So you can't use everything anywhere. There's always going to be basically a trade-off. Those are the two differences. All of our radios have Sigfox, have LoRaWAN. So if the client wants to maintain their own network, or they want us to manage their network, we can do that in the same way. We'll sell them radios, and we'll sell them gateways. The gateway is this device that sits interpreting the radio signal and putting it onto the internet. Sigfox, our biggest seller is the Sigfox radio, because we don't have to worry about anything.
In terms of Sigfox, it's got a limitation on
140.
Yes, correct, yeah. So both of them actually have limitations. One is governed by the network, and the other one is governed by fair usage policy. You can do it, but it's, I'd say, highly frowned upon. There's no law saying that you have to transmit it that, but because you're using the LoRaWAN technology, they try and keep you within the bounds, because everybody else is using the same technology. So you can't just be a bandwidth hog and kill it for everybody else. But you've actually got no say, because it's in a licensed band frequency. So you can't phone ICASA and say, there's somebody on my 868 frequency disturbing it. They say, but you chose to use that frequency, it was free. So that's one thing that we have to remember.
What is that limitation?
So Sigfox, governed by the network, you've got different contracts. So Sigfox, you've got 2 messages a day, you've got 70 messages a day, and you've got 140 messages a day. There's 3 different contracts. This message allows you, say, 1 downlink per day. This one here allows you, I think it's 2, and this one is 4. So you can only theoretically send 4 messages back to the unit per day. This is not strictly implemented, because they kind of take a rolling count. So 4 messages times 30 days. So you can probably send more down, but they do notify you once you're exceeding the limits.
Okay.
Yeah.
Question with the LoRaWAN, obviously because it's not governed by anyone, it's fair usage policy. If you do exceed that, however many messages it is a day, would there ever be a case where they would block you from transmitting? No.
They're just going to send you an email and say, please.
Don't do that again.
Yeah, I don't really know what happens.
Yeah.
There's no governing body to stop anything.
But now on the LoRaWAN, if you've got your own self-contained network,
surely,
how's that affecting anybody else?
They all
the cloud.
Another person might be in the same area running their own LoRaWAN network. So you're transmitting on the same frequency, they're transmitting on the same frequency, and we know if 2 things transmit at the same time, they clash.
But the chance of that's highly unlikely.
Yeah, look, it's not only, there's, I don't know how many channels there are in LoRaWAN. So it's a spread spectrum. So it goes on different frequencies. So that's also a very good part of the newer technologies, that it jumps frequency, which is very good. So LoRaWAN, you don't really have this 270 and 140. You've got a fair usage policy, which basically says out of the day you're only allowed 1% of the day to send.
Jeez.
So it's known as your duty cycle. So if you work it out in terms of time, LoRaWAN can send at different speeds. So if something is further, it will decide to send slower, so that it can get received. If it's from here to there, it can send very fast because it can get there. So you can send a lot more packets faster than one bad signal longer. You know, you could probably fit 10 or whatever it is. So that's all related to the duty cycle of how much, I think it's 1% of the day you should be sending from your device. Yeah.
Then just another question. You mentioned that it hops, not hops, but it changes between frequencies. Is that within that band or?
So it's like 868 point, 868 point. Yeah.
So it's like their
So your
frequency-
gateway is listening on 8. You get 8 channel LoRaWAN gateways, and you get 16 channel.
Okay.
So it's theoretically listening on 16 different frequencies.
Okay.
So that means that you can add a lot more clients all sending at the same time theoretically, because it'll all be spread over 8 or 16. 16 channel obviously costs more than an 8 channel.
Yeah. Is there a limit?
16 is the
16 is the biggest.
We just maybe want to explain what is the urgency of moving to Sigfox and LoRaWAN because of VHF and UHF
Yeah.
and all that falling away.
Yes, so wouldn't be an urgency, but it's highly recommended just because of the cost. The
And
cost
also components that we can't get.
Yeah, well, it's because the cost is going higher and higher, because generally in the world people are not using it. So the availability of these components is less and less, therefore manufacturers are not always making it, and therefore your cost goes up and up because the demand is so low.
I mean, what was that one we mentioned in the meeting where the components like $500?
Yeah, exactly. So just the MOSFET on the VHF costs maybe like 3 of those bi-directional.
I think the one was about $25.
Yeah.
What?
Yeah, we said in the meeting there was one component that
$25.
was 500.
So it's over
Yeah.
500 right?
Over
So
500
it
and that's just for little MOSFET. In
No,
the
that's-
olden days,
that's just
that's this
Just
little
the-
component
just the
here.
one.
I just imagine that's 500 rand cost to make a VHF radio.
Oh,
No.
It's
Without
without
shipping,
our
eh?
cost.
Without landing.
And that's not the radio. That's just that
Just
that one component. So there is good sense in moving to higher technology. It uses less power. Your battery doesn't get killed.
More features.
You've got more fields. You've got more redundancy. You can add more gateways to fill in as you need. And of course, the big thing is the bi-directional.
Yeah.
The fact that you
Plus
can
you can
talk
contain your
to
own
and back.
network.
Yeah, exactly. So that's kind of where we're moving, but we haven't stopped the. But we still got 4G here. We still got 4G. So as the networks maybe do recover and things like that, we will still offer. 4G is sort of unlimited. As you know, you can send as much as you want. You can arm and disarm and keep on sending as you need. So there's no real limit to 4G, which is nice. There's a subset now also, is 4G, on 4G, but it's known as NBIoT. It's kind of a mashup between 4G and IoT stuff. So you're doing like 0G stuff on the cell phone network towers.
Are they piggybanking off the towers? Or
It is Vodacom, or it is MTN doing NBIoT.
Oh,
So
okay.
it's not a third party, which is good, just
So it's
because
the
of coverage.
Towers talking to each other.
No. The tower. So in the 4G frequency band, you've got little bands that aren't really used, which they've decided to use
Those
for
bands
this stuff.
IoT.
Yeah.
Okay.
So
The
NBIoT has.
networks offer that to Sigfox.
So you'll buy an NBIoT SIM card from Vodacom. So this is also something, we've got 1 or 2 projects using NBIoT. So literally we'll have, we still got, you've got UHF here, you've got VHF here. But Sigfox, LoRaWAN, 4G, and it'll be 4G, it'll be that Cat 1, eh? Cat 1. We've got 4G, which is NB-IoT, UHF, VHF, and eventually we'll have Ethernet and Wi-Fi as well. So,
But VHF is going to eventually.
yeah, I see. There's some people that still want to do VHF. So it's very difficult to jam a 15-watt transmitter.
Yeah, because you need something that
It's
transmits.
correct.
Yeah.
And what we have to remember about whatever is sending, if you go back to this thing here, if your jammer is sitting here, it can't jam this thing from sending. It can't stop it from sending. So this thing will still send, which means if you're trying to jam here, theoretically for it not to receive, you actually have to jam.
There.
You have to jam the gateway,
Which is impossible.
which is impossible. Also, if you have another gateway sitting here, you literally have to jam all the gateways to stop receiving that signal.
And that all has to be done simultaneously. You'll have
Yeah,
to jam.
yeah, and you have to know that it's sending at that time to jam it.
Unlikely.
So that's why they say Sigfox is unjammable. Theoretically is jammable, but you have to sit at each one of the gateways that would have received the signal and turn on your jammer there. So that's why they say it's not really jammable here. But what is jammable is the signal back, because now you're just jamming that.
Yeah.
So your callback can get jammed, obviously,
Mm.
like to activate something.
Yeah.
So
On
to
a
be
tracker
so
that would make
anything
sense.
wireless, if people tell you, oh no, this wireless technology is not jammable,
It is.
it's complete junk.
Yeah. Like I say, on a tracker that makes sense, but like on a home alarm panel, it's not
Yeah.
they can jam as much as they want.
Mm.
You're not receiving a signal, you're sending the signal out.
In fact, you want them to jam so that you can detect it.
Correct.